Hi, this is John Landis, Applications Engineer with Trimex Solutions. Today I'm going to show you a SOLIDWORKS top-down modeling technique for creating a brand new part in the context of an assembly. This is pure top-down engineering made possible because in SOLIDWORKS assemblies we lose none of our part modeling capabilities and simply gain assembly modeling capabilities. Here's our old friend, the U-joint, and our goal here is to create a cover on the side of the bracket to keep dust out. Pretty clearly we don't have a part there right now, but in SOLIDWORKS to create a new component while we're in the midst of an assembly, all you have to do is use the Insert New Part tool. When I issue this command, it doesn't look like much is happening. After I pick my template, the software is waiting for me to select a face or a plane. Notice on our status bar here, it even gives us that message. And when I pick a face or a plane, here's what's going to happen. SOLIDWORKS is going to create the brand new part for me. It's going to throw me into part edit mode. It's going to locate that brand new part with the front plane of that new part coplanar with the face that I've selected in the assembly. Additionally, it's going to create a sketch on the front plane of that brand new part and immediately throw me into sketch mode. And that all happens with a single click, in our case, on the side face of our bracket. Notice on my title bar, it tells me that I am in sketch 1 of this brand new part with this funny name. More about that in a minute. The part is part 5, caret in the U-joint assembly, in the U-joint assembly. Notice in our feature manager tree, the part that we are currently editing, this part 5, the text is in blue, which is our visual cue that we're in part edit mode, and we're also editing sketch 1 right now. This part that has been created is a virtual part. Its data has not been yet saved out on the hard drive. The bits and bytes that make it up live totally within this assembly, which is great if you're in an R&D or sandbox environment. Now that we're in this sketch, I want to leverage the edges of the bracket as sketch entities for my brand new bracket cover. So I can pre-select this outside edge on my bracket and then use our offset entities command. Oh, I'm sorry, I meant convert entities because I want the sketch entities that I'm creating to lie right on top of the edges that are currently selected. Convert entities does that for us. It's like offset entities but with a 0 offset. I'll do the same thing with these short edges on our bracket. And then I'll use a nifty little trick that we have available to us with sketch geometry created from convert entities or offset entities. And that is, we can drag the endpoints of open sketch segments that are created through that process. Notice also that our sketch has a number of sketch relations on them. The entities have this on-edge relation which references back to the edges of the bracket. Now all I need to do is simply trim away the extra geometry that I don't need, and we can now see that I have a sketch that is associated with the outside perimeter of my U-joint bracket. The sketch is fully defined, and I can simply exit the sketch and go in and do my extrude boss operation. Give it an appropriate thickness, 60 thou works great, and I now have a cover for my U-joint based entirely on the edges of the U-joint bracket. This cross-part relationship is honored and maintained. Notice if I make any type of modeling change to the U-joint bracket, for example editing one of the dimensions here, when I rebuild my model, the bracket cover updates accordingly and it honors and obeys the revised bracket geometry. Let's set that back to where it was a moment ago. And again, our design intent is honored and obeyed. We can exit out of this file, exit up to the assembly level, and as I mentioned a moment ago, whenever we use this technique to create a new component, it automatically creates that component as a virtual component. Again, this part does not have a discrete file on the hard drive until we tell it to, and that's quite easy as well. We can simply right click on that part in our assembly tree and save that part in an external file. Give it the name that we wish, my bracket cover. Tell it the folder that we wish to save it in, and now this part that previously did not have its own part file is a separate, discrete part file that we can work with like any other part. Again, the cross-part association is honored and maintained. And when I rebuild this part, this assembly, everything updates as we would expect. When you open up this part file, our brand new part file, I want you to notice that we have our single extrude feature in here, but we have a little extra bit of symbology showing up right after the name of the feature, this dash greater than sign. In SOLIDWORKS feature tree symbology, the dash greater than sign means that we have a cross-part relationship, some sort of external reference. And that's clearly evident in our sketch. It is the on-edge relations that provide the cross-part relationship between the bracket cover and the bracket in our assembly. Whenever you see a dash greater than sign in a feature tree or in an assembly tree, you can simply right-click on that item in the tree, and we get a new shortcut menu item, List External Refs. And what this does, it shows us where this particular item derives its information. So it's telling us that the sketch of this boss extrude is deriving information from the edge of the part called mounting bracket. Notice we have buttons here where we can break those links or lock the links. The only difference between breaking a link or locking a link is you can unlock a locked link, but you can't unbreak a broken link. And this actually may be helpful in some cases. Let me illustrate. This technique we use, this top-down modeling technique, is quite helpful when you're in a research and development or sandbox environment, but at some point or another your design is going to be mature enough that you don't want it to update anymore. So now we want to go the other way and break those links that are associated with our parts. So what we can do is simply go to our List External References dialog, choose to break all those links. We get a warning that we will not be able to activate them again. And I want you to notice now that the symbology in our feature tree is still the dash greater than sign, but it has an X that tells us that those links indeed have been broken. And we see the same symbology in the part file. Our sketch is still fully defined. The on-edge relations are still there, but they simply don't know what they're related to anymore. If the design of your part is satisfactory at this point, you can document it, put it through a manufacturing process, and start making parts. Sometimes we may want to do some tweaks to the design. And to do that, we want to get rid of any residue of the cross-part relations. And that's easy enough to do by editing the sketch in this case and simply deleting all the relations, which throws our sketch to a fully underdefined state. And then it would make sense to follow this up with the fully defined sketch tool that brings our sketch back to a fully defined state. We now have parametric dimensions and more conventional geometric relations, and we can tweak the design of this bracket cover, say for example with an offset for spot welding or something like that, quickly and easily. Back in our assembly, again you see that the cross-part relations have been broken. There's absolutely no reference that this guy started life as a new part in this assembly. And the last thing that we would do is get rid of the special mate that was created when we executed on the new part. Notice this in-place mate. The only way to create an in-place mate is through this technique of inserting a new part whilst you're in an assembly. And the in-place mate locks this component in space with respect to the face or plane that was selected when the new part was created. What one would typically do in this case now is delete or suppress this in-place mate. Our brand new part now has 6 degrees of freedom, and we will use conventional conventional mates to locate it in our assembly with accuracy and precision. Again, this is just another top-down modeling technique. I hope you found it helpful. This is John Landis, Applications Engineer for Trimex Solutions. Thank you for your time and attention, and we'll see you in another video sometime soon.